Welcome, class. Let's start talking about the derivative. First thing we're going to do is find the derivative using first principles and what's called the difference quotient. What does that come down to? Well, here it is. Here's my x and my y axis. Here's my y axis and here's my x axis. This here is any old curve. I don't know what it is. We'll just call this f of x. Now, what's going to be important for us to know is that here is some x on my graph, which means this point here is x, comma, f of x. This is x, this is f of x, this is our point x, comma, f of x. I'm going to go over a distance h to come up with x plus h. Now, sometimes they call this delta x. I like to use h. Delta x sometimes takes the place of h. So x plus h gives us this point, x plus h for our input, comma, the function value at x plus h. And I can draw a line through these 2 points, like this. Now, if you channel your inner geometry student, you'll remember that if we have a circle that's intersecting in 2 spots with a line, we call this a secant line. And if we have a circle that just kisses our graph in 1 spot, we call that a tangent line. So a secant line, 2 points of intersection. Tangent line has 1 point of intersection. So when I draw this line here, this is clearly a secant line. And that particular secant line has a slope. So I'm going to say the slope of the secant. Well, we know slopes are change in y over change in x. So that's usually in algebra, you learn it's y2 minus y1 over x2 minus x1. The slope of this secant line is going to be y2 is f of x plus h minus y1 is f of x, if I make that substitution, and x2 is x plus h minus x1, which we call simply x. So there's the slope of our secant line. Now, what happens if I bring this h smaller and smaller? If I drag x plus h closer to x by making h smaller, nay, h smaller, nay, h smaller, nay, h very, very small. So what I'm doing as I decrease h is I'm bringing x plus h back towards x. Now look how small my h is there. If this is my x plus h, look what happens to the slope of our secant line. It's getting flatter and flatter and flatter. Eventually, I can make h so small, meaning 0.000000000000000000000000001 of a centimeter or of a millimeter, so small that x plus h is virtually on top of x, and my point x plus h is virtually on top of my point x. And what happens as h goes to 0, our point, instead of becoming 2 points, becomes 1 point, and our red secant lines become a green tangent line, because now we only have 1 point of intersection. When does that happen? Here's our difference quotient. We're going to take the limit as at not as x, we're going to take the limit as h approaches 0. This distance h is getting smaller and smaller and smaller of f of x plus h minus f of x over x plus h minus x. And this is what's known as the derivative. Here it is, the difference quotient to find the derivative. One of the most important things you can always keep in mind is that the derivative gives us the slope of the tangent line. The slope of the tangent line is our derivative. When we find this derivative, f dash of x, we're finding the slope of the tangent line. F dash of x is also known as y dash or y prime, which is also written as dy dx. These all mean the same. The derivative, we're finding the slope of the tangent. We have to get that in our head and make that connection. Derivative is slope of the tangent.